Hello and welcome back to my channel, guys. So in today's video we are going to learn about how to trace the circuit diagram. So here I have taken one circuit diagram. This circuit diagram is for HFO purifier supply pump. So how this circuit diagram is working we will discuss in detail. So before going in details, first of all we have to learn some basic things regarding how to read a circuit diagram. So in a circuit diagram there are two things. One is power circuit, another one is control circuit. So the top one which I'm underlining is a power circuit. So this we have is a power circuit, and the down one we have, this is the control circuit. So this we have is the control circuit. So there are two parts of a electrical circuit diagram. One is power circuit, another one is control circuit. So how this power circuit and control circuit working we have to discuss in detail. So there are few things like this M. This M stands for motor. So this is our the equipment. This is our equipment, which is motor, and these are the windings of these motors, which are three windings, U, V, and W. This 51 is always an overload relay, OLR. This 51 inside a circuit is always an overload relay, and this 88 is the main contactor. This is the magnetic contactor or the main contactor, and its contacts are open. This A, which is connected in series with the S phase, is the ammeter. So A stands for ammeter, and this 52 we call it as the isolator unit. This is our isolator unit, or also MCCB. So MCCB we know is the molded case circuit breaker, or we can also call it as the isolator unit, because this is isolating the circuit from the main power, and this is our main power, which is RST, and this is coming from the main switchboard. So this main power is coming from the main switchboard, which is actually 440 volts, three phase. So this is our main power, which is coming from the bus bar or the main switchboard, which is 440 volt, three phase, and 60 hertz frequency. So after coming from main switchboard, it is going to 52, which is the isolator unit, and from there on it is going to the input of the contactor, and it is standing over there. Since contactor contacts are normally open, the motor is on standstill condition, it's not starting. So our main focus is how these contacts are getting close. So only thing which is preventing the motor to connect is the contactor contacts, which are normally open. So once it closes, power will go from here through overload relay, and it will go to the motor, and your motor will start. So we will see how these contacts are getting close. Here we can see 440 volt coming through three phases from the main switchboard, and from isolator unit or the MCCB, power is going to the inlet of the contactor, and from there we can see the power is going to the two fuses. These are the main fuses, and from there on the power is going to the transformer. From here on, from these two fuses, power is going to the inlet of the transformer. So here the transformer is having 440 as the in, so this we call it as a control transformer, which is stepping down the voltage from 440 to 220. So once the voltage step down, from here we are getting this as 220, and this is, we call it as the A2, or the power side, which will always have power. So this will go there, it will go through the fuses, and it will go to the other side of the main contactor coil. So this contactor having A1 A2 is always the coil of main contactor. So this is coil of main contactor, because A1 and A2 is the power source which is going inside the coil of main contactor, and then it is getting energized. So one side we saw it's completed. Now we have to see how the other side is getting completed. So also power from here, it will come through this FC2 fuse, and if this is okay, then power will flow and it will go to the normally closed contact of, this is normally closed contact of overload relay. So if motor is tripped on overload, then this will open. In that case we need to reset the motor. So here it is normally closed contact, so power will flow through and it will go here, which is start button. So 3C is always a start button, and 3-O is stop button. So stop button is always connected in series with the circuit, and a start button is always in open condition with the circuit. So what will happen, once we press this start button, this will get closed and power will flow from here through 3-0. Since 3-0 is always closed, it will go to 88. So once this 88 will get power, it will get energized and its NO contact will become normally closed and its NC contact will become normally open. So we have to look for the contacts of 88. So once this getting energized, its NO contact will become closed. So this is normally open contact of 88. So this will close. So now the power will flow from here to here, and this NO contact of 88 will also get closed, and this L is the running indication for the motor. L is the running indication, this is run indication, and LP is the power indication, that control power is there. So this LP is the power indication, L is the running indication. So we'll discuss one more time what is happening here. Once power will come from here to here, once we press 3-C, power will come from here, it will go to this, and this will energize 88. And once 88 get energized, so power will flow from here till here, and it will go to 88, and this will become closed. And once this will get power, it's normally open contact which was here, it will become closed. So this main contactor contacts, they will become closed and power will flow through overload relay to the windings and motor will run. So this is how this circuit is working. And one thing we need to discuss, like this start push button is spring loaded. So once we press this and release, after releasing, power will flow from here through NO through NC contact, because earlier this contact was normally open, and once we press this, it became normally closed. So now this is normally closed, and power, rather than flowing from a start button, it will flow from here, since we already release the push button. Once we release the push button, start push button, power will flow from here, it will go to here, and it will keep energizing this 88. So this is how the motor is starting once we press the start button. So what will happen if we press this stop button? We'll see. So this is our stop button. So once we'll press this, this will open. Once this will open, this we already know this is already in open condition, and if we push this, this line will become open, it will be like this, and there will be no power flowing through this contact coil. So once there will be no power, this will become normally open, and power will come and it will stand here only. No power will flow through here. Power will stand, and again we need to press this start button to make it energize and make the motor running. So this is how the stop button is working. So once we press this stop push button, there will be no power to coil. Since this is also normally open, this is start push button, 88 now also became normally open, so no power will flow from here also. So our circuit will be de-energized now, since there will be no power flowing through the coil. So this will also become normally open and our motor will stop. So this is how this circuit is working, and this is very basic circuit, since we have only one starter and this is actually DOL type. This starter is DOL type, direct online starter, since we have only one contactor involved. So this we called direct online starter circuit. So this is direct online starter circuit. So in this video we learned about how to read a DOL circuit in detail. Thanks for watching my video. Do like, share and subscribe to my channel for more such amazing videos. Thank you.